Yeah.
First rule is you got to make sure that the x squared term has a coefficient of 1. There should be a 1 in front of the x squared. And now we both agree that writing 1 x squared is the same as just writing x squared, right?
Yeah.
Yeah, so I don't have to write 1 x squared. We know that x squared is 1 x squared. Second rule, if I have a constant term, that's a term that does not have a variable. If I have a constant term on the left side, I want to move it to the right side. So then I know that I can move the 2 from the left side of the equation by adding positive 2 to this negative 2, which means I have to also add positive 2 to the right side. So that leaves
Yeah.
me with x squared plus 4x is equal to 2. And we are in harmony so far, right?
Yeah.
All right, so let's go to the next rule. We're going to add something now to both sides of the equation that will give us the numbers that we need to solve this equation a little easier.
Yeah.
You with
Okay.
me? All
Yeah.
right. So let's read all of what it's saying here. You want to set up the problem to add a value that will make a perfect square trinomial on the left side. All right. Now, here's where I have to ask you if you remember what a perfect square trinomial is. And here's
Perfect.
where it's okay for you to say, well, I ain't quite sure what that is. Can you tell me?
Ain't okay. Ain't that what can be? Ain't that can be divided into equal parts, right? Two equal parts.
Well, kind of, sort of. Now, let's take let's take the easiest one I can think of. X plus 1 squared.
X plus
That
one
is what we
squared.
call a perfect square trinomial. Now, if we simplified it, do you know how to use the FOIL method? Multiplying the first, outer, inner, and last terms.
Uh,
That's fine if you don't. But
no.
I don't want to use it now if you don't know what it is.
Wait. If I probably just think if you show me, I'll probably remember. I
All
don't.
right.
I don't. I probably don't remember. But
Well,
if you show me, I'll probably.
bear with me now. I'm asking you that now because it might take us down a rabbit trail to talk about FOIL at this point. So what I'll ask you instead is just believe me when I tell you that x plus 1 squared, when I simplify it, is x squared plus 2x plus 1. And it simplifies that way because it's what we call a perfect square trinomial. Perfect square trinomials have nice numbers. That might be the best way for me to say it. You don't have
Okay.
fractional numbers, you don't have decimals, you don't have square roots. You have nice, whole, round numbers.
Um,
And they are desirable because when we're dealing with perfect square trinomials, we can solve them without pulling out tools like the quadratic formula that may cause us to make errors when we're trying to apply all those rules. We like perfect square trinomials because they are very easy to solve with our eyes. You feel me?
yeah.
Okay. All right. So let's go back to what we're trying to do over here on the left side is add a number that will make this a perfect square trinomial. Now, I know that the number that will do that is 4. You believe me?
Yes.
If I put a 4 on the left side of the equation, that will give me x squared plus 4x plus 4, which simplifies to x plus 2 squared, the entire quantity squared, x plus 2 squared. You with me?
Okay. Yes.
But for the benefit of being able to set the left side up like that, mathematical law says whatever I do to the left side, I have to do to the right side. So if I add 4 on the left side, follow my cursor, then I have to add 4 on the right side.
Well,
Gotta observe the rules and maintain the laws. But the benefit of doing so is now on the left side, I got something that I can factor with my eyes. But the cost of that benefit, if you will, that's what life is all about, man. There's cost and benefit to everything. There's pros and cons and strengths and weaknesses. The price I have to pay on the right side for the convenience of what I just did on the left side is now I got this number 6 that I got to deal with on the right side. See that?
Yeah.
But I'm going to be able to deal with it. I will pay that cost because I like now having an equation that I can solve with my eyes. Because if the left side of the equation can be factored as x plus 2 squared, if I want to solve this for x, I think I know how to do that without pulling out the quadratic formula. If I've got a squared term and I want to solve just for the x term, I take the square root of both sides. That sound familiar? And does that sound like I'm being consistent in whatever I do to one side, I must do to the other side? So I'm going to take the square root of both sides. Now what I know is if I take the square root of x plus 2 squared, that's just x plus 2.
Yeah.
You believe me?
Yeah.
All right. And
yeah, I remember it.
All right.
I remember square root.
And then if I take the square root of 6, I have to remember that square roots are positive and negative. So I've got to remember that the square root of 6 has a positive root and a negative root. So I got to account for both of them with this plus or minus sign. That simply says that x plus 2 squared, when I take the square root of it, it is equal to positive square root of 6, and it's also equal to the negative square root of 6. But instead of writing two different equations, I write one equation and I use this symbol to indicate both of those values make this equation true. You with me?
Yeah.
All right. So now I have taken a difficult polynomial and manipulated it into a simple equation to solve, because if I've got x plus 2 on the left side and I want to solve for x, what do I need to do to both sides of the equation?
Find the square root.
No, I did the square root already. Now I just have x
No.
plus 2 and I want to solve for x.
Okay. Wait, say it again. I wasn't paying attention.
All right, here, stop looking at what we're doing for a second now. Just give me your mind, and let me talk directly to your mind. If I have a number, any number, and by adding 2 to that number, I end up with 4. What number did I start with?
Started with.
I got a number. I want to add 2 to that number and end up with 4. So what number did I have to start off with?
Yeah, 2.
All right. Let's say I got a number and I want to add 7 to it to end up with 9. What number do I start with?
Started off with 2.
I started off with 2. Now what you are doing in your mind, which tells me you understand what's going on, is you say, hey, you have some number x that when 7 is added to it, you end up with 9. X plus 7 equals 9. Well, to figure out what x is, I subtract 7 from 9. And that's how I know that x is 2.
Yeah.
That's what you did. I am not accusing you falsely, am I?
No,
that's exactly what you did. Now, that's all you do
no,
here.
I really just knew simple math. Like I know 2 plus 7 is no.
Well, believe it or not, man, when you are a 50-year-old grown man, and I happen to be a 50-year-old grown man, being able to solve very simple equations in your head, that will never go out of style, man, and that will never cost you money. That might actually make you some money. You believe me?
Yeah.
People don't walk around saying, what is the square root of 737? Nobody asks people stuff like that. Nobody asks people the square root of anything, man, in the real world. But now if you in a store and something costs 20 and you hand the cashier 40, you looking for $20, right?
Yeah.
Everybody knows that. And everybody's got to be able to do that kind of math in their head. Because if you're looking for 20 and they give you 10, you might have to give them 10, if you understand what I'm saying, to get the rest of your money.
Yeah.
All right. So let's get back to this now. So all I have here is some number x plus 2 is equal to plus or minus the square root of 6. So it looks a little weird, but this is no different than the equations you and I just solved through conversation in our head. You believe me?
Yes.
All right, so if I want to know what x is, the mathematical rule says, well, if you want x on the side by itself, Derek, you got to subtract 2 from the left side, which means you have to also subtract 2 from the right side.
Yeah.
And that's what's going on here. But the notation and the numbers don't allow it to look quite as simple as us figuring out that if I add 7 to a number and get 9, that x is 2. It doesn't look the same, but it really is the same. It really is the same. And you and I did an easy example in our heads so that I could convince you that all you do with this more complicated looking one is you do the same thing, man. You follow the rule, you apply the rule, and then you check yourself. That's all you do.
Yeah.
And you did all of that in that mental exercise. You did all of that in real time in your head without thinking about what you were doing. Now, when the numbers are a little more complicated, yeah, maybe you got to think about what you're doing just a little bit more, but that's okay. You do enough of these problems, it will become as familiar to you as having a number and adding 7 to it and ending up with 9. You'll be able to do it in your head because you have put in some training and some time and built up some strength.
Yeah.
You believe me?
Yes.
All right. So what we have is x plus 2 is equal to plus or minus the square root of 6. I'm going to subtract 2 from both sides. When I subtract 2 from x plus 2, I can write that as x plus 2 minus 2, which equals what?
0.
No.
Wait.
I still have an x, right? Now the plus 2 minus 2 equals 0, but I still have that x. That's important because that's the number I'm trying to figure out.
Yeah. So it's x equals 0. Wait, right?
No. What I do to one side, I have to do to the other. What I did to the left side was I subtracted 2.
Yeah, so you must subtract.
So I must subtract 2 from the right side.
Yeah.
Now on the left side, I'm going to end up with something clean. I'm going to end up with x, right?
Yeah.
On the right side, I'm going to end up with something that's not so clean. But remember the cost and benefits we talked about before. I wanted to use this method to manipulate the left side into something that made the left side easy to deal with. But the cost that I'm paying is now the right side might look a little crazy.
Okay. Yeah, it's gonna be like a bunch of decimals and stuff.
Right. But the important thing now, the first important thing is that x, since I have subtracted 2 from the left side, x is going to be equal to minus 2 plus the square root of 6, but it's also equal to minus 2 minus the square root of 6 because of this notation which says both positive square root of 6 and negative square root of 6 are solutions to this equation.
Yeah.
So I have two answers for x. I have minus 2 plus the square root of 6. I have minus 2 minus the square root of 6.
Yes.
All right. Now tell me how all that is working for you now.
It's not. I get it. It's not confusing. I get it.
All right. Now what cements it, man, is what you do at Ingenuity, where they will say it to you in a slightly different way. But now, I promise you, they're going to observe the same rules that I've observed, but they're going to do it with different examples. and they're going to do it with different words. And now, if I may say so, Travontae, what impacts students in math the most are not the numbers, man. It's the words. So I try to be very careful in the words that I'm using, and I say them at a very deliberate pace so that you have time to catch them, or so you have time to say, hey, I'm not catching that.
Okay.
And if you don't catch it, then I will either find some other words or I'll use the same words again, because sometimes all it takes is hearing it a few times.
Yeah.
The other times, it might take, say it a little different, man. Say it a little different. Other times, what it takes is for me to shut up, man, and to let you talk and allow you the time to put into words what you're not quite catching. And a lot of times when you do that effectively, it will tell me exactly what to tell you now, because you have told me what you don't know. And now, I'm not sure how you define intelligence, man, but I define intelligence as knowing how to say you don't know. Because there's a way you can say you don't know that will convey an attitude that won't have anybody fool with you at all. But there's also a way you can say I don't know that will communicate, hey, I'm almost right there, but I just need a couple of dots connected. And then that might make it easy for somebody else to help connect the dots, because they can at least see that you care and that you want to know. Does that make sense?
Yeah.
That can make all the difference in the world, man. All right, I'm off that soapbox now. But now, do you see this example? This is not a perfect example by any stretch, but it is straightforward enough, and the words are straightforward enough where whenever I need to remind myself of how to complete the square, this is my resource. I come right here to this page, man. I have looked at this page probably 20 times in the last year. Because 2 days from now, remember now, after you leave me today, I have another student coming who's in a totally different class. We're going to be talking about some totally different things. So 3 days from now, Travontae, I'll tell you a secret. I'm probably not going to remember all the steps in completing the square. But you know what I do remember? Here's what I remember. I remember that whatever I do to one side of the equation, I got to do to the other side of the equation. And I remember my resource that I found at MathBits. So I can very quickly remind myself of how to complete the square. Now, I aged myself. I told you I'm 50 years old, man. Can you imagine that over those 50 years, there might be a few things that I have learned and learned very well?
Yeah.
Now, the confidence that that generates for me, Travontae, is if I don't know something, man, I don't worry about it. That just means I ain't supposed to know, but I can find out. Because what I know, I know I know. And what I don't know, well, I know what I don't know. And the things that I don't know, I can go and find out.
Yeah.
Because nobody knows it all, man. And you don't have to know it all. You just have to know what you know. And you got to know what you don't know.
Yes. Yeah.
All right. All right. So, you came to class today. That is a wonderful thing. Boy, I hope I'll see you again soon. Now, tomorrow, I won't see you now because Fridays we don't have Zoom meetings.
I know.
Yeah, but I sure hope I see you Monday. And if I don't see you Monday, I ain't gonna throw you away, man. I would just hope I see you on Tuesday. Because nobody comes every day. But now, the more you come, the more you and I can do what we doing right now.
Yeah.
So what are we doing right now? Now, in your words, what are we doing right now?
Understanding each other.
We are really understanding each other, definitely. See, that's why I like to shut up, man, and hear what my students are thinking over on the other side of the conversation, because you are going to use words that I might not use. But those are good words. Yes, we are understanding each other. We sharing knowledge, man. That's what we doing.
Yeah.
Sharing knowledge. And sharing knowledge, man. This ain't all about me telling you what I know. This is about me offering something to you that I have some experience with, and then shutting up long enough to hear how you are receiving it. And if you receive it, then cool, I'll tell you something else. If you don't receive it, well, I'll tell you the same thing. I'll try to tell it to you in a different way and make sure that you get something out of it. Or if we don't, if this whole conversation ended in you still not understanding, then I would say, well, look, man, just come back and get with me again the next time you got time, and we'll pick up where we left off. This don't all have to be finished right now and today. Some things are going to take a little more time, and all we do is give it time. Now, I guarantee you, if you talk to anybody else that's been in any of my other Zoom classes, they would probably tell you I'm crazy because we've been doing the same problem for the last 2 weeks. I said, yeah, well, yeah, that might sound a little crazy, right? But what I know is if you and I get this one right here, the rest of it is going to be a lot easier to you. So I would rather stay with you on this for 2 weeks than move on and know you ain't ready to move on, because I know you're going to run into something else even worse. I'd rather stay right here where we are, as crazy as that sounds.
No, that don't sound crazy.
Yeah, because the worst thing that happens there, man, is Dr. Taylor might call me up and say, Derek, what you doing? And then I'll say, sir, what I'm doing is I'm making sure they get this one so that they'll have a better chance of getting the next one. Now, if you want me to just skip over this one, then the same situation we got right now, we're going to have it again on the next one. And it'll probably be a little worse because you'll have a student that has building frustration. And you let your frustration build up too much, then you just say the heck with all of it. And that is the absolute last thing you want to happen. So trust me. That's what I'm saying. You hired me to do this job, man. Trust that the way I do it might look a little strange every now and then, but just, I know what I'm doing. I know what I'm doing. And that's what makes PLC a pretty cool place to work at, because I get that leeway. And being online, having you engage the same lesson, but in the ingenuity way, that's helpful to me because I at least know that between now and the next time I see you, you'll be able to hear something from somebody else and get some practice in. And if you run into a problem, maybe you run into a problem that you can say, well, coach, can you look at this one for me? And then me and you will look at the problem. We'll figure it out. We'll move on. Because one of those two things will always happen, man. We will figure it out and move on, or we won't figure it out and move on, because there will be other problems to solve, and there will be other problems that we can't solve, man. But that's okay, as long as we engage it with the understanding that we have. Even if we don't solve it, hopefully what we did will build us a little more problem solving muscle, so that the next challenge we run into, we might be a little better for it. Travontae, does that sound like math, or does that sound like life?
Like life.
That's life, young blood. Yeah. Yeah, you're going to engage many battles, man, and end up with a couple of scars. And you might not be able to give out any scars. Well, that's what happens sometimes, where you take that, take it as a lesson, and then you do a little better next time. That's how it is in math too, man. Trust me, you would be able to find a problem in ingenuity that I can't solve, man. That might take you a minute, but you'll be able to find one that I can't do, because I know I can't do all of them. But what I rely on is, hey, I got a long history, man, of things that I have been able to do. So I rely on the confidence that I get from that, and I rely on my resources. So what we do a lot in these Zoom calls, I just showed you my Math Bits resource. Now, if you were here earlier today, I had another Algebra 1 student who's in a different lesson than you're in, where they had to visualize what a function looks like the graph of a function. Yeah. And I asked them if they knew where the graphing calculator was in Ingenuity, and they said no. And they said, man, I'm kind of dumb, ain't I? I said, no, watch this, man. Guess who showed me that Ingenuity had a graphing calculator? It was one of my students, man. Showed me. I didn't know it was in there. But now I do know about graphing calculators, and I was using a graphing calculator, but it was outside of Ingenuity. So it was kind of clunky for us to be in Ingenuity and then have to jump out and then go to the web browser and find it in the web browser. Students say, why are you doing all of this when the same calculator is right here in Ingenuity, and they went and opened this menu and clicked this button, and I'm like, wow, I never would have seen that there, man. Never would have seen it. And trust me, it's the exact same calculator that I use. It is built into Ingenuity. But see how something that
Yeah, I
subtle,
know.
man, is very helpful to a student to know that that tool is there and that it's there to help you see what's going on. Because when you can type the equation in to the graphing calculator and have the graphing calculator show you what it looks like, man, that is so helpful. That is so helpful.
Yeah.
I have aged myself enough, but when I was in school, man, we had no such tools. So you either saw it or you didn't. And you either remembered how to do it or you didn't. We didn't have math bits. We didn't have the internet. We didn't have calculators. So that means I missed out on a whole lot of math, man. I got a lot, but I missed out on a whole lot. So yeah, what I got was there are certain things, man, that I have memorized so cold I will never forget. But that also means I spent so much time memorizing that stuff, man. There's a lot of other stuff I never got to see. So what you'll see about education, man, is the way you work around that. Hey, there's some things that are around nowadays that weren't around in my day. What you do, Travontae, is you stay in school forever, man. Well, not in school, but you know what I'm saying. You learn forever. Never stop learning. I found math bits last year when I got to PLC, and I never had a reason to look for it before I ended up in the situation I described earlier. I'm teaching all these classes, man. I got to cover a lot of stuff that I ain't really up on. I need something to help me get up on things. And that's when I went and found it. You ever heard this saying, man, that necessity is the mother of invention?
Yes.
Yeah, so you know what that means?
Um.
Well,
Wait, say it again. I
I'm,
think I do.
I'm gonna tell you what my
Wait, say it
daddy.
again.
I'm gonna tell you what my daddy told me, man. Necessity is the mother of invention. My daddy said that means, man, when you need something and you really up against the wall, you'll figure out what to do. That makes sense?
Yeah. Yes.
And that's what it takes sometimes, man. You get your back up against the wall, man. You will think of something. So anyway,
Oh.
let's come out that rabbit hole, man. Sounds like we had us a good time today. And I guess what Sanaya was saying to me earlier was that she's not gonna come until 2 o'clock. I guess that's what she was saying. The girl that was on when y'all called during lunch.
Yeah.
Yeah, so let me sign off with you now. I'm gonna go ahead and get ready for her at 2 o'clock. And so I'm gonna see you again. So I ain't gonna hold you to let me see you on Monday. But if I see you Monday, man, I'll be glad to see you. How's that?
Okay.
All right, and try to knock this quiz out that you're on now so I can peek at it between now and Monday. And if you got it, good, let's move forward. If you don't have it, then we'll pick up on Monday and work through the actual quiz.
Okay.
Sound like a plan?
Yes.
All right, my man. Then be well now, and I will see you. Well, I'm gonna see you when I see you, but hopefully I'll see you Monday. All right.
Okay.
Okay. Take care now.
Okay.
All right. Bye.